Hello, everyone. My name is Sandeep Nair. I'm a senior program manager in the Azure Cosmos DB team. And in this presentation, we will look at Azure Synapse Link for Cosmos DB. Let's start with understanding what is Synapse Link for Cosmos DB. Synapse Link for Cosmos DB enables the HTAP capability, which basically allows us to do real-time analytics over the operational data in Cosmos DB. And while doing that, it minimizes the impact on performance on your transactional workload. It does this by integrating Azure Cosmos DB with Azure Synapse Analytics. So there are two products that are involved here. And currently it's supported on the SQL API and the MongoDB API of Cosmos DB. Let's look at first how analytical workloads were run without Synapse Link. The simplest example is you run your analytical workload and your transactional workload on Cosmos DB. There are two big problems here. One, both workloads, since they are running on the same compute, they are competing for it and it can lead to performance degradation. Two, the cost of running analytical workload is on Cosmos DB can be very high. So what is an alternate approach? The alternate approach is you can separate OLTP and analytical workload on Cosmos DB. You create an ETL pipeline, take the data from Azure Cosmos DB, dump it into a data lake, and then on the data lake, use your Apache Spark or your Synapse SQL to do your analytical workloads. Now, this approach saves us money. However, it adds management complexity because now you need to manage your own ETL and storage and all the other infra. So both solutions are not great. That's where Azure Synapse Links for Cosmos DB comes to your rescue. It basically breaks down the barrier between the OLTP store and the OLAP store. So you get both worlds together. And this capability is called hybrid transactional and analytical processing, or HTAP. Let's look at how does HTAP work in Cosmos DB. So what you see right now is the transactional store or the row store of Cosmos DB. The operational data is written to that. When you enable Synapse Link, Synapse Link would create a columnar store or an analytical store in the backend, and it will automatically sync data from the row store to the columnar store. Once the analytical store or the column store is available, you can use Azure Synapse to do your analytical workloads. You can use Apache Spark or SQL Serverless and run various types of workloads like machine learning, big data, or dashboards. And you can all do this in real time or almost near real time without having to spend too much time setting up any infrastructure. So on the left-hand side, you have your transaction store, and on the right-hand side, you have your analytical store, both working together and fully managed by the platform. So the benefits that we see here is that the data from the transaction store moves to the analytical store almost in near real time. It's less than 2 minutes. The two stores are completely isolated, so there is no performance impact from each other. There is a cost reduction of running your analytical workload on Synapse. because we use SQL serverless and Apache Spark there, which are cheap resources and do not burn RUs. The data from Cosmos DB, which is a NoSQL database, is automatically inferred by the analytical store. We infer it in two ways. It's called well-defined and full-fidelity. I will talk about this topic a little later in detail. Since the whole platform is managed by Cosmos DB, there is no additional workload or headache to set up compute, throughput, storage, or anything. The data that you put in Cosmos DB is available in all regions. So wherever you have a Cosmos DB, you also have an analytical store. So you do not have to worry about geo distribution of your analytical workload. Also, there is a concept that the time to live or the TTL value for the analytical store and the TTL for the transaction store can be different. So what happens is you could use that to optimize your storage on Cosmos DB. You could retain only hot data, live data on Cosmos DB, and you could put all your historical cold data in the analytical store so that you are optimizing on costs. So we talked about schema inference. So we have two types of schemas inference. One is called full-fidelity, other is called well-defined. When we talk about full-fidelity, as you see in these two documents, the purchase date in one is string, in the other one it is a number. So when full-fidelity schema inference happens, there are two columns that are created in the inferred store, whereas if it was well defined, the data type would be based on the first occurrence. So if the string column was the first occurrence, then it would the column will be string type. If integer was the first occurrence, the column will be of integer type. And any subsequent data, if it is incompatible, it would be skipped. When we talk about schema inference, we have some restrictions. We can only read max 200 properties from the JSON file, and the JSON should not have more than 5 nesting levels. If there are more than 5 nesting levels, those properties will be skipped. Also, the columns in the analytical store are not case sensitive, which basically means that if your JSON properties are case sensitive, when they are inferred, they will combine and that can create chaos. So a recommendation is to use different property names in your JSON and not depend on case sensitive property names. From a pricing perspective, there's a huge cost advantage of using Synapse Link for analytical workloads. We see approximately 63% cost reduction. The primary reasons why there is such cost reduction is that the analytical store, first of all, compresses the data up to 5 times. And you do not spend any cost for syncing from your row store to your column store or from transaction store to your analytical store. That's taken care by Cosmos DB free of cost. You only pay for storing the analytical store on ADLS2, which is cheap, and you pay for compute, which could be SQL serverless or Synapse Spark runtime. But again, those are cheap resources. So you do not burn your costly RUs for doing any of the workloads. You spend very little for storage and compute when using Synapse for your analytical processing. Let's move to a demo and see how all these concepts are applied. The problem statement that we are going to address here is that we are going to create a application that is going to do the billing for a mobile network called Contoso Mobile. We need to track all incoming and outgoing calls, where the customer should be able to view all the recent call history. We need to generate a bill on a monthly basis, and the bill should include the total cost for that month and the usage history for that month. We also need to build some kind of analytics that can be used by the Contoso team for improving their product offering. So we are going to design a solution that integrates with the calling app of the mobile network. We understand the service should be always available. It needs to provide low latency. It has to be geographically distributed. And because we're talking about a mobile network where millions of people are connected, we need to have high throughput. So we are going to use Cosmos DB as our backend database. For doing the analytics, we are going to use Power BI. And for the bill generation, we are going to have a backend job created in Spark. Let's see how HTAP will be applicable in our scenario. So we have the real-time calling application interacting with our transaction store here. This transaction store, because of Synapse Link, is automatically getting translated to the columnar store here. And then this columnar store is used by the SQL serverless, and it is used by the Power BI application. The same columnar store is also used by the Apache Spark runtime to do some batch processing. So it basically generates the build document through the batch processing. And once the batch processing is complete, it writes back data to the transactional store. So the Apache job is doing two things. It is reading from the analytical store and writing back to the transactional store. By doing this, what we get is the best of both worlds. We have on the left-hand side an application which has got low latency, high throughput, and it is globally distributed. And on the right-hand side, we have the backend processing applications which are able to use the power of T-SQL, joins, aggregations, etc. And they are not using RUs, so they are cost effective. Let's also understand the different data documents that we are going to use in this demo. The first document that we are interested in is the call records document. In this document, if you see, we are interested in the three fields that are highlighted in the blue box. The subscriber ID is the ID of the caller, which is supplied to us by the calling application. The bill cycle is the month followed by the year. Again, this can be calculated from the date and time, current date and time. And then we have a field which is called PK, or the partition key, which is a combination of the subscriber ID and the bill cycle. Now this PK or partition key is used to partition our data into, so that whenever we scale up, we are able to provide high throughput. This partition key will allow us to make sure that the data for a subscriber is always stored in a single partition. Therefore, we don't have to do cross joins or cross partition queries. Two, by storing the data for each customer in a separate partition, we are also avoiding hot partitions. So this design will allow us to scale up to a very large number without causing any kind of throttling on the platform. We can, like I discussed earlier, we can also use the TTL to limit the number of records that are there in the transactional store. We can store only 2 months of data and we keep the historical data on the analytical store. So that's another way to further reduce the load on the Cosmos DB. The second document we are interested in is the build document. This is a document that is generated by the Spark runtime. And here what we are seeing is that we have an ID, which is again similar to the PK that we saw in the previous document. We are copying the PK for a single subscriber and converting it into the ID here. We are having a cost field, which is a calculated field. This is calculated by the Spark runtime. And then we have an array, which is a list of all the calls that were made during this build cycle by this subscriber. So again, this is being done by the Spark runtime. So these are the two documents that we are having. So let's start with the demo. To start with, let's first go to our Cosmos DB and see the two containers that we have. So here is our build document container. Let's see if it is empty. Yep, it is empty. And let's now look at all the call records container and see if that's empty. Yeah, both of them are empty. So what I'm going to do is I have two console applications that I have created, which are basically generating fake data. So let me run this application so that it generates some fake data. So it is generating some 15 call logs, and I will run this also to generate more fake data. Okay, so we have 115 records that have been inserted. Let's just refresh here and see if the data is available. Yeah, we can see some data is available. Let's go through this data and make sure that it is as per our requirement. So we have the subscriber ID, we have the build cycle, we have the PK, which is as per our requirement. The other additional information that the call logger application is generating is when was the call started, when did it end, how much was the duration, from which number to which number, and then some additional fields like whether it's a local call, an international call, from where was the call made, etc., etc. So let's just see one more document to make sure that all the documents are intact. Yeah, looks like everything is good. So we have inserted the data into Cosmos DB. Now let's see if this data is available in this query. So let me just execute this query and see if this data is available. Okay, I can see 115 rows were found here, and this is the data that we just inserted. So you may be wondering, how come we inserted data into Cosmos DB? And here I am in SQL Server Management Studio and I'm running a view. And how did that data come here? Now this was enabled through Synapse Link. Let me explain how it worked. So let me switch to Synapse workspace here and let me open the view here. Here we have the first statement, which is to create the credential. So what we need to do first is we need to secure our primary key from Cosmos DB and store it as a credential here. So we do that by using this command, which is to say create a credential. Once we do that, the next statement that we want to do is to see how to read this data. So let me just collapse this so that we have some more space. So we use select star from open row set so that we can connect to our database and read the data. Now to do this, we provide our account, our database, the table, and the credential. So we created the credential on the step 1, and now when I execute this, I will be able to get the data. So this is enabled through the Cosmos Synapse Link for Cosmos DB. Now we see the data, but you would see the data is coming as JSON strings here. The reason why they are JSON strings is because of the full-fidelity schema that we have. So each column also has got a data type associated with it, so that for each data type, there is a separate value that is stored. Now, if I have to run some queries, it is very difficult to run here because of the data type that's here associated with each value. So let me unpack this data set, columns, so that they become regular rows and columns like you see in a RDBMS. We do that using the with clause. So when I say with clause, I have to provide the data type and the path from which it has to be read. So for each column, I'm going to provide what is the data type of the column and from where it has to be read in this JSON string. So let me just run this and see what happens. OK, so once I use the with clause, you can see that the data has got cleaned up, it has got unpacked. And now if I require, I can also add a filter and filter on this column. So let me just apply a filter and see if the data is changing. Yeah, so it is working fine. So this is now a regular table which I can operate using SQL. So I have now a SQL table ready, but the next question that comes up is, OK, there's a table ready, but this table is inside Synapse Workspace. How do I use this in my application? How do I use it in, let's say, in Power BI? How do I take this out? So to do that, what we do is we create a database in Synapse Workspace using the create database command. And once you create the database, that database will get listed here. I have already created the database, so I'm going to skip that step. And then once that database is created, you use the create view command followed by the SQL query that we had on the top to create a view in this database. So once you do that, this query that we have built here becomes a view and is now available in this database. So let's me again go back to SQL Server Management Studio and show it again in action. So we created a view here in this database, and this is our server, which is the server provided by Synapse, and it is an on-demand database, which basically means that you only pay for executing the commands. This is not a dedicated server that you have, it is on demand. So this is SQL serverless. So the cost of running this is fairly low. Let me see if this query can be used in a Power BI dashboard. So I've already created a Power BI dashboard. If I hit the refresh button, it is going to connect to the view and it is going to get the data from that view. So if you see, it is connecting to the on-demand database and it has got this 115 records and it has painted a dashboard. So similarly, you could use the SQL serverless to connect to your third-party application and do whatever you want to do. Please note the SQL serverless compute is running outside the Cosmos DB compute. So it is not, whatever you do here is not going to impact your main application, the transactional workload. Your client applications are not going to have any impact of whatever you do here. So we saw how we can run analytical jobs on Cosmos DB using Synapse Link. Now let's see how some background jobs can also be done. So for doing that, again, let's go back to our Azure Synapse workspace. And this time, let me open a Synapse notebook. I have this notebook here, which is now here. What we are doing is we are going to use Spark runtime, and through Spark runtime, we are going to read data from the analytical store, and then we are going to do some processing of the data, and then write it back to the transaction store. So to do this, the first step is, first of all, we need to add Cosmos DB into Synapse Workspace as a linked database. So to do that, we go to the data tab, we click on the linked tab here, we click on plus, we click on connect to external data, and then we select either Cosmos DB, MongoDB, or Cosmos DB SQL. In this case, ours is a SQL database, so we select SQL. You can continue, you provide the details to connect to your SQL database, and then it will get added here as a linked database. In my case, I have already done that, so I'm going to skip that step. Once your database is added as a linked database, we are going to load the data from that database into a data frame. And again, in this case, we don't have to provide the credentials here because it's a linked database and this database details are already stored in Synapse. So let me just run this and see what the output is. Okay, so we are able to get some data. The data is again, because of the full fidelity, is again packed with the data type in front of it. So, and in Spark, there's the option to see the data frame schema. So let's just see the schema, and you can see that for each column, a data type has been inferred and it's available to the print schema command. So now that we know the schema, let's use that schema and unpack the data frame and make it clean. So here we are giving the df.column_name.data type to unpack it. And once the unpacking is done, then we are also renaming the columns so that we are able to get a proper row column format in a data frame so that we can run some operations on it. We are also typecasting the date time here because it comes in as string when you do a regular inference from Cosmos DB SQL API. So now the columns are unpacked, the typecasting is done, and I have also applied a filter on June 2022. So this is the data for only one bill cycle. What we going to do next is that we are going to convert this data frame into a nested data frame. The reason why we are going to convert it into a nested data frame is because we need to, in the build document, we need to create an array of these details for each subscriber. So we are going to create a nested data frame, step 1, and then next we'll also aggregate it. So let me just do the data nesting here. So once I do the nesting, you would see that a new column got added, and in this column, all the columns that I supplied are added as nested fields as JSON here. So now I have got the call log details or combined details for the call log for each record as a separate column also. The next thing that we are going to do is we are going to calculate some cost for each call. So we have a very basic formula for calculating the cost. We are saying for each, if the call is an incoming call, then there is a certain charge. If it is an outgoing call, then the charges are different. Of course, this is a very basic logic. It will vary in a real business environment. Yeah, so we have calculated the cost, and you would see now a new column for cost has been added, and depending on the number of seconds that the call happened and the type of call, there is a cost that was calculated by the logic. Now that we have the cost and the data for each call in a separate call called log, let's do some aggregation and combine them to create our bill data frame or your combined data frame. So now we are seeing that there is data for 3 subscribers, and we have the data, the log details here. So for different, so for this person, there's lots of calls. So we have this data available like this. And for these 2 guys, the number of calls are far less. Now that this data is available, this is the equivalent of our build document but in a data frame format. Let's use the data frame.save command to write this build document back to Cosmos DB. One thing that you would notice here is that earlier when we were reading from Cosmos DB, the format was cosmos.olap, and now we are writing to oltp. So it is using the same link database, but the format is different. So at this point, we are connecting to the transaction store. There is going to be cost of writing data into the transaction store involved here, but till now there was no cost involved from Cosmos DB side. Only this, depending on your document, the write cost to your Cosmos DB will get added to your Cosmos DB bill. So when we execute this command, for each subscriber, it is going to generate 1 item in Cosmos DB. Let's switch to Cosmos DB and open the build document and see if these details are available here. Yeah, so those details are available here. So let's just open here so we can see that the data is available. So here we have got an array of call logs for this subscriber. So what we saw here through this demonstration was that we were able to move data from our transactional store to our analytical store without any ETL in almost real time. There was no complexity of running an ETL job or managing it or anything of that kind. Everything is managed by the platform. There is no impact of the transactional store on the analytical workload or the analytical workload on the transactional workload. Both are running on independent stores. The cost of operation is very low because we don't use RUs for the analytical store. RUs are only used by the transactional store. All the compute and storage are used by Synapse is cheap, so you are able to do your work at a much cheaper cost. Also, there are multiple tables that are there, and you could do joins in analytical store, which is not possible in the Cosmos DB transaction store. Last but not the least, you could have all your customers all around the place. So you could have multiple regions where data is getting written. The analytical store will be created in each region. So your data processing can be done at the region that is closest to you, and Azure Cosmos DB will make sure that all data is available at all regions. So that's the demo that I wanted to show. I hope you liked it. Thank you very much.